All right, here's another one in the series that we are calling We Love Dimensional Analysis. Woohoo. Okay, this problem comes from, again, first chapter in Zumdahl. Not a chemistry problem necessarily. There's a lot of good chemistry here, but a problem-solving approach. You pass a road sign saying New York, 112 kilometers. If you drive at a constant speed of 65 miles per hour, how long should it take you to reach New York? That's the first part. Okay, that's part A. Okay, and then part B says, okay, if your car gets a whopping 28 miles to the gallon, how many liters of gasoline are necessary to travel 112 kilometers? It doesn't say anything about trading in your car for a better mileage model. But in any event, let's do the first part. If you drive at a constant speed of 65 miles per hour, how long? That means time. Let's do it in hours. How many hours will it take you to go 112 kilometers? Pretty simple. But again, the toughest part of the problem is to come up with what are you looking for and where are you going to start. Once you've got that, then you let the units drive the problem solving. Don't worry about any calculations. So we've got kilometers. I need to get the miles because I've got a conversion factor that's given to me in the problem that's in terms of miles per hour. If I can get in terms of miles, I'm in business. Okay, so I'm going to show you a roundabout way. Everybody could go into Google or whatever and Google that conversion factor. But the reality is that we can go a longabout way. I happen to know that 1 inch is equivalent to 2.54 centimeters. That was somehow branded into my mind when I was a young undergraduate student, and it stuck with me for all these years. So here's what we do. Conversion factor time, kilometer, 10 to the third meters. Kilometer cancels kilometer. Meters on the bottom, centimeters on the top, 10 to the minus 2 there. Meters cancel meters. All right. Now that I'm at centimeters, I can use my conversion factor here. I know I want the 2.54 centimeters on the bottom, and I know I want the 1 inch on the top. Centimeters cancel centimeters. Oh, growing up in the good old US of A, most of us know there are 12 inches to a foot. Inches cancel inches. I've got feet, and less of us know that there is 1 mile is equivalent to 5,280 feet. Always amazes me people who don't know that, but that's okay. Feet, cancel feet, I've got miles, okay? Continue the problem down here. Now that I've got miles, what can I do? I've got a conversion factor in the problem that says 65 miles per hour. I want miles on the bottom, and I want hours on the top so that miles cancel miles, right? Okay? And then finally, hey, no finally to it, I am done the problem. Now I just need to do the quote-unquote trivial part, doing the calculation. Please notice that during the problem solving, I did never use the word multiply, divide. I didn't touch my calculator until I got the units correct. I'm pretty confident that when I have gotten the units that I want and the units at the end matched up, that I have done the problem solution correctly. So now is the time that you touch that high-priced calculator and you do the calculation. So we turn it on, we'll clear the screen, and now we'll do the calculation. 112 times 10 to the third. Notice the way I use 10 to the third. Again, your own style. E to the 3 is the same as 10 to the third. It's probably the most efficient way to put 1,000 in with just 2 punches on the keyboard. I'm going to divide by e to the minus 2. Scoot the calculator out of the way. I'm going to divide by 2.54. I'm going to divide by 12. I know how much you love watching me do the calculation. Divide by 5,280. Divide by 65. And if I've done everything correctly, the calculator spits out lots of digits there. How many digits should I keep? I've got 3 sig figs in the 112. These are exact calculations. That's exact, that's exact, that's exact. I've only got 2 sig figs here, so my answer should have 2 sig figs. And so if I go back and look at my calculator, I should write that answer as 1.1 hours. Okay, 2 sig figs. Great. Good. Let's do the second part of the problem. Second part of the problem says, if your car gets 28 miles to the gallon, how many liters of gasoline are necessary to travel 112 kilometers? Okay, so how many liters? Come on, pen. There we go. How many liters do I need to go 112 kilometers? Okay. Boy, I'm really going to do the same thing here, 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 and here. Okay? So I go through that. I'm going to go back and convert kilometers to meters. Kilometers cancel. I'm going to convert meters to centimeters. Meters cancel. I'm going to convert centimeters into inches. So I'm repeating myself here, but when you're new at this, it doesn't hurt. I'm going to convert inches into feet using this conversion factor. And then finally, feet into miles using this conversion factor. Okay, so duplicating a good bit of effort there. At that point, I've got miles. Now I'm in great shape. My car says, the problem says my car gets a whopping 28 miles to a gallon, so I'm going to continue the problem down here. I'm going to use that 28 miles per gallon as a conversion factor, but in my case, I want the 28 on the bottom in the denominator because I want miles to cancel. Gallons in the top. Miles cancel miles. I've got gallons. I'm feeling pretty good about this problem. Gallons are a unit of volume. Liters are a unit of volume. Unfortunately, they're 2 different measurement systems. So then I've got to look up, remember, or whatever, that there are 3.78 liters per gallon. Gallons cancel gallons. Bingo. I've got liters. Liters are the one I wanted. Now I'm done the problem. Go back and do the calculation. And if I do that, I'm going to repeat myself again. Okay. Trust me that if you do the calculation, the answer works out to be 9.4 liters. Okay. And again, 2 sig figs because in the problem, 3 sig figs here, exact, 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 exact. 2 sig figs there. We're down to 2 sig figs. Okay? Hope that helps. Keep working problems.